joined by our speaker, Ravi Shankar. Well, this is going to be a tech talk on advancing in analytics and business performance in real time with logical data fabric. We're looking at talking about the notion of logical data fabric and the need for such architecture in modern data analytics. We're looking at talking about real-time performance innovations delivered through cost-based algorithms and intelligent query optimization engines, and the use cases from the customer deployments that have delivered business successes. We've got Ravi Shankar, Senior Vice President and Chief Marketing Officer, Denodo. Well, Ravi is a published author and a frequent speaker on data management and governance. He's responsible for Denodo's global marketing efforts and his deep expertise in data-related technologies, helping enterprises to adopt modern data integration and data management solutions. Thank you so much, Ravi, for joining us. Over to you.
Hello, my name is Ravi Shankar. I'm the Senior Vice President and Chief Marketing Officer for Denodo. Today, I'll be talking about advancing analytics and business performance in real time with logical data fabric. If you look at the condition right now with the pandemic, the recession has forced a reality among us. First of all, the revenue has been cut down because of the post-lockdown, and many people are not buying as much as they should. So the reduced revenue has actually driven people to the companies to basically reduce the amount of money that they invest, especially like in IT, the budgets are cut. And also from a staff perspective, in some of the companies, they have actually let go some of the people. So the new normal is that we are operating with reduced budget and reduced staff. And for us to be able to not only survive in such a climate, but also to thrive, we need more business agility. We need the ability to be more creative, to be able to move forward with making more revenue with less staff and less budget. So in order to get there, it's very important that the technology needs to provide the agility for the business to be more agile. But quite often, the technology is not in a position where it provides the agility for the businesses to quickly react. And as a result, we saw many businesses that actually went out of business last year because they were not able to adapt very quickly. So quite often in the technology landscape, you will see a diagram like this, in which the businesses have multiple different systems. They're all stored in different locations. For example, some of them could be on premises, some of them could be on the cloud, and the data could be in multiple different formats. It could be in a structured data repository like a data warehouse or a database. It could be unstructured information that is actually coming from different sources like social media, from the IoT and so on. And it could also be in various degrees of velocity. Some of them could be data at rest, such as the data within a data warehouse or a database, or the data could be in motion, just like the IoT technology that I mentioned. Constant streaming information is actually coming in from the devices. So there's a plethora of different conditions that actually make for the data landscape to be very difficult. And this poses a problem for the IT to integrate the data into a cohesive unit and provide all that related data to the business users immediately so that they can make the right decisions. So that particular challenge exists. So you ask the question, how do I basically integrate all this data in real time and provide this the unified view to the business users to make decisions? And last year, Gartner actually came up with this particular notion called data fabric. In fact, back in 2019 itself, they started predicting that in 2020, this notion of data fabric will take on. So we will learn more about what the data fabric definition means, but here the key technologies that will go into that, and especially one of them is data virtualization, which is a form of data integration. So we will talk more about that particular one in the subsequent slides, but here is where the data fabric comes to the aid of providing that unified view. So if you look at this particular diagram, it is similar to the one that I presented just a few minutes before, in which you have multiple different systems all the way ranging from databases, which are structured storage. You could have your data warehouse in which you're bringing the data through ETL into the data warehouse. You could be having data lakes built on Hadoop or NoSQL or any other kind of systems. You could have cloud object data stores and you're storing the information within there, or even local repositories like your like a spreadsheet, your Word document, and so on. So this is how the landscape is, but the business users consume in terms of knowing all the customers and what are the products that they basically buy, or which are the customers that have actually filed claims. For example, if you're in the insurance industry. If you're in the healthcare or the pharmaceutical industry, you're looking at compounds that actually make up the different drugs associated with the products that they go into. So all this kind of brings together through a data fabric. A data fabric is an architecture. We will define it quite frequently pretty soon, but you can actually see that it is a net that actually integrates all the data underneath it and provides that cohesive view or by each data object, and also the relationship among them, customers related to products or customers related to claims or products related to compounds. It provides that, that related view as well. And Gartner is not the only one that has defined this data fabric. In fact, other analyst firms such as Forrester have been talking about data fabric around the same time. They have been talking about it more so from a big data fabric in the previous years. But last year, they adopted this enterprise data fabric in which they released a wave, in fact, and Denodo is actually named one of the leaders in this particular one. And similar concept as to what Gartner talks about, and we will look at the definition right now. So here, Gartner defines the data fabric as an architecture pattern. It's not a product, it's an architecture pattern that informs and automates the design, integration, and deployment of data objects, regardless of the deployment platforms and architectural approaches. So what this basically means is that data could be in multiple different ways, but the data fabric tries to bring them together, integrate them together, and make it available as a cohesive view. And it uses continuous analytics and AI ML over metadata assets to provide actionable insights and recommendations on data management and integration and design and the deployment patterns. So what this means is that in providing that integrated view, the data fabric needs to automate much of the manual functions using artificial intelligence and machine learning. And the data fabric is an architecture that contains the metadata. It contains information about the data where all this data is actually stored. And in doing so, it provides that the related information using these metadata assets. And finally, this results in faster, informed, and in some cases, completely automated data access and sharing. So the objective is to provide the data as quickly as possible to the business users so that they can affect immediate outcomes. And here is Forrester with a similar definition: dynamically orchestrating disparate data sources intelligently and securely in a self-service manner, and leveraging various data platforms to deliver integrated and trusted data to support various applications, analytics, and use cases. Similar definition, again, orchestrating disparate data sources, data is distributed, provide a unified way in a self-service manner, and provide that as an integrated way, and also have it, all these different applications, especially like analytics, kind of consume that from this integrated source, which is the data fabric, and make it available to those applications and business users. Now, let's dig a little bit deeper beyond the definition. So, and again, we will look at two architectural components, one by Gartner, another one by Forrester. So here is the one by Gartner. So let me parse this out. You actually look at it as 3 layers. So the bottom layer is where the data sources are. So that's the multiple different repositories that I showed in the earlier Gartner diagram. And then you have the data consumers at the top. So these are the business users that are consuming the data through various applications. It could be reporting applications, it could be portals, it could be any other applications that the developers have actually built. The middle layer is the data fabric layer that integrates the data across these sources and makes it available to the consumers. So you can see the 5 pillars, which is what Gartner defines. in terms of having an augmented data catalog, a knowledge graph enriched with semantics, active metadata, insights automation layer, and final data integration and orchestration layer. So these are the 5 pillars that make up the data fabric, and they provide this integrated and related view to the data consumers. Forrester is a similar definition. So although it is a little bit more elaborate, it has about 5 different stacks here. So you can look at the ingestion and streaming and data movement, bringing the data from these different sources, and then persisting that into a Hadoop or a data lake. And from there, it actually takes on the transformation and the cleansing aspect of this data, which means the data is stored in multiple different formats. Now it is starting to prepare the data for consumption purposes. And that's where the 4th layer, which is the data modeling, preparation, curation, and the graph engine come into picture, so that the business users can conduct data discovery on top of that. And the final layer is basically the access part of it, where it is distributed through in-memory, self-service, and APIs, which different applications consume, and then they use the data. And one thing common that you see is the AI ML across all the 5 different levels. And that means automation has to be in every single layer, providing automated information and automation of much of the manual tasks. Okay, so this is what is called a data fabric architecture. Now, the data fabric could be either a physical data fabric in which you're storing all the data, or it could be a logical approach where you're connecting to the sources but not collecting them into a physical repository. The one diagram that we look at here is a physical data fabric, whereas a logical data fabric will have the same representation without the persistence part. And the challenge with the persistence is that it takes time to store the data, it costs money to store the data, and very quickly the data will get out of sync with the sources. So a logical data fabric architecture is preferable to a physical data fabric architecture, and we will delve a little bit more deeper along those lines. So one of the core components of the logical data fabric that provides that unified view without having to persist it is the data virtualization. So data virtualization is like a logical data layer, and that is that red layer that separates the underlying data sources that are disparate across multiple different locations, formats, and latency, and provides that unified and related view to the business users at the top who are consuming that through either reports or portals or any other application. Here are the 6 components within the logical data fabric, and one of the key ones is this notion of data abstraction. It disintermediates the underlying sources from the consumers at the top, and by doing so, it separates the IT and the business. Now, IT can go about modernizing their platform, moving into the cloud, and so on, without disrupting the business. The business comes to the data virtualization layer and asks for the data. The data virtualization layer has a very good understanding of where this data resides, whether it is on-premise, on the cloud, in which format it is, and it never still provides that unified view. And it does the integration of the data, which is the second point. And the third point is the access part, of the ability to deliver this within the business applications that the business users can consume. And in doing so, the data virtualization layer, because it's an enterprise data layer that contains all the data, it becomes the place where you catalog all the information, where the data is resident, what format it is, who's the owner of it, who's accessing it. So it can provide all that information. And the 5th point, in doing so, it provides the governance in terms of the history, the lineage, the security, all of it, it actually provides. And the last one is the format in which it gets delivered. You can consume it in whatever format that you want, within reporting applications, within traditional applications, operational applications. So there could be various ways, but the data is delivered in those formats. Now, data virtualization and data fabric are on the Gartner hype cycle. The one that you see here is called the Gartner hype cycle for data management, which was published July of last year. And in the hype cycle curve, you see data virtualization all the way to the right, which is the plateau of productivity, which is where the technologies have become more stable because they have been around for a while. Data virtualization technology has been around for a couple of decades. So it is more stable and it is more prevalent, more used. But whereas the notion of the data fabric is at the peak of hype cycle, the peak of expected inflated expectations, because this is a new terminology that has come into picture, and it comprises data virtualization as one of the key components in addition to others. Now, if you haven't heard about data virtualization, you're probably not noticed that it is one of the most widely used technologies within the IT portfolio. So here is a question that Forrester asked among its about 2,000 plus clients that they surveyed, in which the clients actually mentioned that data virtualization is in their plans for data management over the next 12 months. So it's one of the top technologies that is used within the organization. And so now, if you did not know that before, now you know that. Okay. So let's get a little bit deeper into the technical architecture of the logical data fabric, because many of you in this conference might be very technical. So again, we are looking at the three-tier architecture. We have the sources underneath, and then we have the logical data fabric, and then we have the consumers at the top. And the logical data fabric connects to the underlying sources. And in this case, the Denodo data virtualization has over 150 adapters across multiple different sources. It could be a traditional database or data warehouse. It could be a cloud stores. It could be Hadoop and SQL or NoSQL. It could be OLAP cubes, even local files, whether it's Word document, Excel, and so on. And any applications of streaming data, or even applications present on the cloud, such as the salesforce.com, where there are specific connectors. So it connects to all these underlying sources, various formats using JDBC, ODBC, even API connectivity. So it can connect in multiple different ways, and it can bring together the data, whether it is structured data, unstructured data, it brings them all together. And that middle layer over there is the one that actually is the logical data fabric that contains much of the secret sauce in terms of how it processes this data, both from an integration perspective as well as from a consumption perspective. So the first point here is that it is kind of real time, that the data is actually brought together from the sources in real time, and it is delivered in real time. So the data is as fresh as the sources. And then there is the acceleration that data virtualization provides in terms of optimizing the queries by pushing them down to the sources and bringing back only the results to the data virtualization layer, and making the results available to the business users through the applications very fast. And in doing so, you can actually cache that information within the data virtualization layer, so you don't have to go to the sources every single time. So you can actually pick it up from the cache, and then you can deliver it. And it contains artificial intelligence and machine learning, which is one of the core requirements of the data fabric. And it automates much of the logical the functions, and it provides recommendations on top of that. And then it contains other things like the governance, security, and so on. And on the top, we provide a data catalog. The business users can conduct data discovery, but also you can use SQL to consume this data within existing applications, your analytical applications, or even data science applications. And you can run R and Python on top of the data virtualization to do the analysis. And finally, API access is also available so that you can build SOA-based applications on top of the data virtualization layer and make that available to your business users. So let's take a look at example here. Seacoast Bank is a regional bank based in Florida, and they were acquiring many different banks, and they wanted to cross-sell and upsell. So they could be a retail bank that acquires a mortgage bank or a wholesale bank, and they want to be able to provide these cross services to other customers from the companies that they acquired, but they had trouble in doing so. That is because the underlying data sources were all different. They were all disparate, coming across these multiple different companies, and they wanted an integrated view of that information. And you see that FIS down at the bottom, that's that financial information system that provides that unified view. But since it was an external system controlled by a third party, they wanted to bring in the data fabric inside in-house. And their approach was, should I go with a physical one or a logical one? So a physical one would have taken them about 8 months to do, but they went with a logical data fabric enabled by the data virtualization. So they provided a virtual data integration layer, and they created virtual data marts, which are basically views on top of the integrated data. And the business consumers can consume using SAS, which was the dominant analytics application, and also Tableau, to understand the data, whether it is finance teams trying to understand the risk assessment of the person who has applied for a loan, or doing like credit verification. So all those functions were done through each of these data marts. And they were able to, first, as I mentioned, cut down the time to deployment. So they were able to get this running in 4 months, less than 4 months, as opposed to 8 months for a physical data warehouse. And also the reports, custom reports that would come out of this system would now take only 3 hours as opposed to 3 days before, because a lot of it was using like dynamic formats. So data virtualization and the logical data fabric did provide an elaborate ability for Seco's Bank to be more dynamic and agile and nimble. And that is only one of the companies among a plethora of them that are actually using the logical data fabric for providing this integrated view of the data and delivery of that to the business users. So with that, let me conclude my presentation here. Thank you very much for listening to this presentation, and make sure you listen to the panel session that is coming right after this. So I will be on the panel, and also visit us at the virtual booth, and we'll be happy to answer any questions that you might have. Thank you very much.